We begin with the points 2, 5, and 16, 14. We sketch an arrow with an initial point here and a terminal point here. The terminal point is the one that has the head on the arrow, the one that is right at the point of the head of the arrow. Okay, then that arrow, this arrow, which we call A, and put an arrow over it to make it a vector, to indicate that it's a vector. This arrow represents a displacement vector A, and that displacement vector will go from the point 2, 5 to the point 16, 14. Now, we want to know what the components of that displacement vector are. Well, we draw a fundamental triangle with sides parallel to the coordinate axes, and we get A sub y and A sub x as the displacements from here to here if we go first parallel to one axis, then to the other. Now, this displacement is in the y direction, so we call it A sub y, and that displacement is clearly 9. Why? Because y equals 5 at this point and y equals 14 at this point. To go from y coordinate 5 up to y coordinate 14, we have to go 14 minus 5, or 9 units. And then A sub x is 14. Why? Because we have to go from x coordinate 2 to x coordinate 16. Our horizontal displacement then is 14. So this vector represents the result of a vertical displacement of 9 units, horizontal displacement of 14 units, and that vertical and horizontal displacement will displace from the point will move us from the point 2, 5 to the point 16, 14. Now, so we say A sub x is 16 minus 2 is 14. A sub y is 14 minus 5 equals 19. Then we say that we're going to use a notation here that represents the vector as an ordered pair, but to distinguish it from an ordered pair of numbers, which would be the way we represent just a point in xy, in our xy coordinate system, we put an arrow over it to indicate that it's a displacement of A sub x units in the x direction, A sub y units in the y direction. In the case of this vector, a displacement of 14 units in the x direction, 9 units in the y direction. Again, the arrow represents that this is a vector, and in this case, we call it a displacement vector. There are many other kinds of vectors. We'll see at least one other kind before we're done here. Okay, so now what's the length of this arrow? Okay, if we're going from 2, 5 to 16, 14, what's the length of this arrow? Well, the Pythagorean theorem will easily give us the length, and coincidentally, the two displacements we have here, the 14 and the 9, give us the x side of this triangle, or the x leg, and the y leg. Okay, so here we have one leg of the triangle, here we have another. This is a right triangle whose hypotenuse is the arrow representing the vector A. So the length of the arrow by the Pythagorean theorem is just the square root of 14 squared plus 9 squared. And if I did my arithmetic right, that's a square root of 275. And that's, I think, approximately 16.7. So we write then absolute value sign around the A vector, meaning the length of the A vector, or the magnitude of the A vector, and that's square root of 275, or 16.5. That would be the distance from this point to this point, and we call that the magnitude of the vector A. Now, we displace, okay, we apply the vector A, but now from the starting position 39. Now, A is, that's 30 comma 9, not 39. Okay, then the horizontal displacement corresponding to this vector is 14. The vertical displacement is 9. In other words, this vector tells us go through a horizontal displacement of 14, a vertical displacement of 9. Then that occurs wherever the vector starts. So if the initial point of the vector is the point 30 comma 9, then what's the terminal point? Out here on top of the arrow, at the point of the arrow. Well, we go 14 units from our x-coordinate of 30, we go 14 units in the horizontal direction. That gets us to a position where the x-coordinate is 44. Then we go up 9 units, okay, starting from 9, that's going to get us to the y-coordinate 18. So this same vector can be used to displace, to move us through the same displacement starting at any point. So starting at 39, this vector will displace us to 44:18. Okay. Now we're going to add a third vector, or a third point and a second vector, but we'll do that in a subsequent video.